My name is Suresh from Hyderabad, IARE College, Department of Civil Engineering. So in today's class, we discuss correction for local attraction by prismatic compass. Now, what is local attraction? So see here, when we place a compass on the tripod stand, and if any object is moved close to the compass, the needle will deviate from its position. The deviation of magnetic needle from its position due to external forces is called local attraction. So the external forces or external material which deviates the magnet from its position is called local attraction. So it may be a metal wire or metal rod or electric pole or mobile phone or a bunch of keys. So the deviation of needle from its position will give you a lot of wrong data. So how to correct the correction for local attraction? Using prismatic compass. So your aim is correction for local attraction by prismatic compass. And apparatus used are prismatic compass. So you have a prism in the compass as you seen earlier, and you have a double disc needle on the prismatic compass. The needle is resting on a pivot, and you have a horse hair here and reflecting mirror. So you have a socket here, and you have a tripod stand as shown here. So you will clamp, you fix the compass to the tripod stand and you keep it on the point and you perform centering and leveling on the ground surface. And apart from these two, we require ranging rod of length or height 3 meter and pegs. We require ranging rod, pegs and a measuring chain of 20 meter length or a 20 meter length tape. So tape and chain are sufficient to measure this experiment. Now, let us see the procedure. To find the correction for local attraction, first of all, let us take four sides, A, B, BC, CD and DA. Now, from four sides, with the help of this prismatic compass, you place a compass at station A. At station A, you place a compass. From A, you take the bearing angle towards B. Okay? From A, you take the bearing angles towards B. Now, from A to B, the forward bearing is 60 degree. And now you take the back bearing from A to D. Okay? You take the forward bearing A to B, and you take the back bearing A to D here. Now, you shift the compass to point B. From B, you take the forward bearing B to C, you take the back bearing B to A. Okay? And shift the compass at point D. From point D, you take the forward bearing from D to C, you take the back from C to D, and take the back bearing from C to B. Shift the compass and place over point D as shown in the figure. From D, you take the forward bearing DA, you take the back bearing DC. Now, record the data, whatever you have seen in the graduated circle. Now, we have the graduated circle here. So, here the least curve of prismatic compass is about half degree, that is 30 minutes. Now, after recording the reading, what we have observed in the field, that is from the traverse, you check the readings here. So, the forward bearings and back bearings are recorded here. So, we mainly know that the forward bearing and back bearing differ when angle of 180 plus or minus 180 degree. So, when you compare the difference between forward bearing and back bearing, these two are plus or minus 180, it is satisfied. When you take the forward bearing and back bearing of BC, that is A, B, C, D, you compare these two, which is not plus or minus 180, it is less than 180. And here also, it is not exactly 180 degree, it is less than 180 degree. And here also, at DA, it is exactly 180 degree. So, we will check which sides have local attraction, which sides do not have local attraction. This happens due to the disturbance of the needle with external material. It may be your mobile phone or the metal rod or the steel material which attracts the magnet. Okay? Now, after doing this, we check the back bearing and forward bearing readings or forward bearing and back bearing readings. It should be plus or minus 180. If not, you find the interior angle at A, interior interior angle at B, interior angle at C, and interior angle at D. To find this ABC interior angles, we have the following. There is formula: previous bearing line minus next bearing line, or back bearing minus forward bearing line. So using this formula, that is back bearing minus forward bearing line, you find the interior angle at A, interior angle at B, interior angle at C, and interior angle at T. So you get the 4 interior angles. After getting the 4 interior angles, you go for the check. So check 1 says that sum of all interior angles are equal. That is, angle A plus angle B plus angle C plus angle D should be 360 degrees. Now, here we are saying that there is some local attraction because side BC and side CD are not exactly 180 degree. So these are plus or minus, these are more than 180 or less than 180. Hence, the sum will not be exactly 360 degrees. So we have to subtract or add. That is, suppose your angle is 352 degree. Okay, your angle is 358 degree. Okay, suppose the sum of angle what you got after the sum is 358 degree. The remaining is 2 degree error. If error is negative, correction is positive. If error is positive, correction is negative. So when you do the sum of the angles, what you obtain in the traverse, which is not exactly 360, it means that there is some error. You divide that error with number of sides having error. So total error is suppose 2 degree. The 2 degree by number of sides having error. In this table, side BC and side CD have error. So total error by number of sides. Total error by number of sides will give you the distribution of the error. So here error is 2 degree, suppose sides are 2 degree. So if you take 2 degree by 2, it is 1 degree. So this 1 degree is a correction for the error. So here this 1 degree is added at station B and station C as shown in the figure. So after adding the 1 degree, again you go for the check of sum of all interior angles. Let's check 1. So when you add all the angles, if the total satisfies to 360 degree, then your traverse is error free. That is, you have done the correction. Similarly, you have another check. It says that 2n minus 4 into 90 degrees. Here n stands for number of sides, number of stations. A, B, C, D. So we have 4 stations. So 2 4s 8 minus 4 into 90. So 4 into 90, 9 4 36. So it is 360 degrees. It is another check. So like that we have to tally the 2 checks. That is 2n minus 4 into 90 degrees and sum of all angles is equal to 360 degrees. So if these 2 checks are satisfied, then your experiment is error free and you have satisfied the correction for local attraction if any. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.